now we are going to commence trigonometry and bearing topic, which is the selective chapter for this masterclass. Okay, so let me just confine my sharing to the whiteboard. Just hang on for a second. Let me restrict the sharing to the whiteboard here so that there wouldn't be much clustering around. Alright. So let's begin with the trigonometry, what exactly the trigonometry concept is. You see, if you just try to move to a history of trigonometry a little, just for the sake of acquaintance, what exactly a trigonometry thing is. You see, trigonometry is the combination of three Greek words, trias, goni, and metron. So let me just write down here. Okay, now I must say that if anybody is having trouble in viewing the whiteboard or in listening my voice, please write it in the chat box, and I'm definitely going to consider it. So this is it. So what exactly this trias means? Trias means three, goni means sides, and metron means measurement. Okay, so the study of the three sides figure is called the trigonometry. Alright, so you see, in trigonometry, you study what kind of triangles. You study the right triangles, you study obtuse, acute, scalene triangles and all that. So with respect to the shape or with respect to the interior angles values, we study a couple of formulas in order to find out the unknown sides or unknown interior or exterior angles of the triangle. We are going to discuss here the types of the formulas, when we use which kind of formula. That's all we are going to study in the very first step. So this is the crucial thing to know. Okay, so if I just say that in the beginning, we just pick up a very easy going triangle. That is called the right triangle. It's not an easy going, it's the most famous one, right? So if we just try to draw here a right triangle, I must select the line option, not this arrow thing. Okay, now here. Let's just pick up here a right triangle. Here you go. You know that a triangle in which one of the angle is 90, that is the right triangle, or you also call it a normal triangle, an orthogonal triangle. There's various names here. So in order to find out any of the unknown sides length or any of the unknown interior angle, which formulas you use here, that's the major thing. So I just say, in order to find out the unknown sides, let's pick up the text option. Whenever we try to find out the unknown side of any right triangle, we take the help of the Pythagoras theorem. You see, Pythagoras theorem is applied only in the right triangles. Okay? So whenever we want to find out the sides, we use and whenever we need to find out the unknown interior or exterior angles, we take the help of trigonometric ratios. Okay? help of trigonometric ratios, which are sine, cosine, and tangent. We know that. Trigonometric ratios and Pythagoras theorem are only applied in the right triangle. Alright, remember that. And then, once when we jump to our those triangles which are not containing 90 degrees in its interior angles, it could be obtuse angle triangle, it could be acute angle triangle. So in those triangles, if we need to find out the unknown sides and the unknown angles, over there we are going to use cosine law and sine law. So before approaching to these laws, let me just write down here the Pythagoras theorem formula and your ratios, just for the sake of formality. We have to be a little exhaustive in our work. So this is the formula of your Pythagoras theorem. Okay, this is your base and perpendicular, and this is the hypotenuse. Like this is your hypotenuse, this is your base, this is your perpendicular. You can name it any term you want. So usually we use ABC for that sake. You can use your hypotenuse square plus base square. Any terminology is going to work here. Okay, so that's it. And once when we talk about your cosine ratio, sine ratio, and we talk about our tangent ratio, students often find difficulty in remembering the ratios formula. So that purpose, we just ask them to remember just one sentence. With the help of that, you can easily remember these ratios adjustment. What is that? I'm just going to write down. Before writing down, I must write the ratio here. So this is base upon hypotenuse. This is perpendicular upon hypotenuse. And this tangent thing is perpendicular upon base. And that's it. Now, how do we remember these ratios formulas? Because it's a little confounding here to remember. So for that purpose, you can just memorize this little interesting statement. On that basis, you can remember these ratios things. And it is this. Okay. People might be thinking what exactly this clumsy thing is all about. You see, from here you can pick up your S, and S stands for sine. From here you can pick up your people, and people P represents perpendicular. Okay. H stands for hypotenuse. Alright, you see, sine is representing perpendicular upon hypotenuse. You can remember it from here. Similarly, curly C is representing cosine. Brown B represents base. Here is representing hypotenuse. So cosine is equals to base upon hypotenuse. You can remember from here. Okay. Now similarly, this through T represents tangent. Proper P represents perpendicular, and your brushing B represents base. From here you can manage the tangent ratio, which is perpendicular upon base. So I hope this statement will help you in remembering the formulas. It's all about that. So once when you just move from the right triangle, where do you move? You move to the obtuse or acute angle triangle. So if you're handling a triangle which is either obtuse or acute, we talk about scalene triangle, having all sides different, having all interior angles different. So over there, if I ask you, try to find out an unknown side length or unknown interior angle value, which formulas you're going to use. Of course, these trigonometric ratios and Pythagoras theorem are not going to work there because it's not a right triangle you're handling this time. So what exactly you're doing here? You are going to use cosine law and sine law. Let me just draw here a little easygoing acute triangle like this. Okay. That's it. Okay. Now I'm going to name the vertices. Let it be A, this is B, this is C. The length, which is, you know that these are the vertices, the endpoints of the triangle called the vertices. The side which is right opposite to any vertex, you represent the length of that side by the small letter of the vertex. Okay, presently it is capital A, so the opposite side to this vertex A is BC, so I can represent my BC length by small a. Okay, the side which is right opposite to vertex B is AC. I represent this length by small b. Similarly, the side which is right opposite to vertex C is AB. I am going to represent it by small c. Okay, that's what normally we study in the theoretical, in the theory of the trigonometry out there. You can use any representation you want, but the representation that is normally used, I'm just picking up that. Okay, so that's it. Now, if I say, when I'm going to use sine law and when I'm going to use cosine law, because I've been given two major formulas, so which formula is going to fit in which situation? Okay, you should know that. So what do? When I talk about my cosine law, or cosine rule, or cosine formula, when do you use that? Okay, you're going to use in two situations. Okay, the number one situation is that if in the question all the sides values are given to you, all the three sides are given to you, and they ask you about the unknown interior angle. Over there, you can use your cosine law. Okay? If I talk about a triangle, for example, it's containing, it gives you all three sides lengths. Okay? And I ask you to find out this interior angle. Alright? So once all the sides lengths are given to you, over there, you can use your cosine law to find out the interior angle. Clear? In the same manner, when two sides are given to you and the interior angle which is present at their intersection, if that is given to you, then in that case you're going to use your cosine law to find out the third unknown side and the remaining unknown interior angles. Okay, so if the two sides are given to you and the angle which is present at their intersection, let me just write down here, angle which is present at the intersection of the two given sides, if they are given to you, then you're going to use your cosine law. Okay, what is the cosine law? Let me just write down here. If I say that I need to find out this side, C and B are given to me, and this interior angle A is given to me, what is going to be the cosine law? There's a full derivation out there, but I'm not going to discuss this right now. I'm just going to focus on the formulas. Okay? Angle A. Okay? So this is the formula of the cosine that you use. Whatever the unknown side is given to you, it is going to come in the subject position, and the sides which are given to you will be placed over here. Okay, and the angle which is present at the intersection of the given sides are placed over here. Just remember this thing. No need to memorize the formula. Try to understand the logic here. Okay? So this is the cosine law that we use. And then when do we use the sine law? Let me just go here. Let me just remove this messy work. Okay, so when do we use the sine law? We use sine law in two situations. And what is that? When the two sides are given to you and one of the angle which is not present at their intersection. If, for example, if I say that these two sides are given to you and any one angle which is not present at their intersection, if that angle is present over here, okay, then you can use your sine law to find out the remaining unknown side and the remaining two unknown angles. Okay, remember in cosine law we use SAS that where angle is present at the intersection of the given sides. And here in the sine law we use SAS when angle is other than the one which is present at the intersection, okay, of the given sides. Okay, remember this. Now the second condition is that when any of the two angles and one side is given to you, then you are going to use the sine law to find out the other two sides and the remaining unknown angle. Okay, so this is it. Another point to be noted is that all the three interior angles of a triangle, their summation is always going to be 180. Why is that? The reason is that you have studied polygons, right? And the formula of the sum of the interior angles of the polygon is given to us here. Sum of the interior angles, sum of the interior angles of any polygon can be calculated with the help of this formula. N minus 2 times 180 degrees. Okay. What is n here? N is the number of sides. Clear? So when I talk about my triangle, triangle is the very first polygon, very first figure in the family of the polygons. So when you talk about your triangle, you have three sides there in the triangle. So you just substitute over here, you multiply by 180. So this thing reveals that the sum of the interior angle of the triangle is always 180. Okay? So the sum of interior angles of triangle is always equals to 180. So if two angles and one side is given to you, then the third angle can easily be calculated with the help of this concept as well. Okay, you can subtract the two given angles from 180, you can get the third angle. So this is it. So I just explained you in summary when you use the Pythagoras theorem and the trigonometric ratios, when you use sine law and cosine law. Okay, and what is the sine law? I forgot to write the formula of the sine law. The formula of the sine law is this. Sine of interior angle A divided by the side which is opposite to vertex A equals to sine of interior angle B divided by the side which is opposite to vertex B equals to sine of interior angle C divided by the side which is right opposite to vertex C. This is the formula of the sine. We have a complete descriptive derivation here, but I'm not discussing this in this master class. We have to focus on the past paper questions. That's why I'm just focusing on the formulas and the conditions when you use these formulas. Okay? So cosine law and sine law, I hope that you have understood that when we use, in which conditions we use these formulas here. Okay? Now the third thing that is crucial to understand is the bearings. Okay? So what exactly a bearing is. You see, it is actually a procedure that we use for the navigational purpose, especially in the voyages, in the aquatic journey. Okay? So if I just say that you are on a voyage and your ship is present at a certain position. I call it point A. Okay. This is the position where your ship is presently standing or maybe locating. Okay. And you are up, your trajectory is to move and reach at this point. Or it could be an island, it could be another ship position that you have to meet, or you have to collate with. So it's all it depends on the situation. If you have to move from A to B, it's like that. So this is it. So how you're going to understand the navigation, that at which angle do I have to move, what should be the route, how can I reach at this point, so how I'm going to decide the track where I have to move on, and so that I can easily approach to the destination point. So for that purpose, you use various navigational methods to find out the distance and the location of the particular destiny point. Okay, so bearing is one of them. Okay, so how you understand the bearing? If I just say that I need to find out the bearing of A from B, bearing of A from B, alright, how you're going to find this thing out? For that purpose, remember, the point which is written after from, you're going to develop a north axis at that point. Okay? You gently try to develop your north axis. Like this. And you are going to calculate the angle starting from this north axis and ending at this line segment AB. Okay, and you are going to move in a clockwise order. Okay, you're going to move according to the direction of the clock. So you have to move like that. This is going to explain the bearing angle where this point B is located with respect to point A. So this will help you in assigning the track or the trajectory where the ship is going to travel. That's all about it. This is all the navigational procedure. So this is it. And if I just say that I need to find out the bearing of B from A. Likewise. So for that purpose, where you're going to draw the north axis, you're going to draw the north axis at point A. Okay, and you're going to move in a clockwise order starting from the north axis. You start calculating the angle in a clockwise order till it ends at line segment AB. This is going to be the bearing value of B from A, and this is going to be the bearing value of A from B. Remember, the bearing angle is always expressed in 3 digits. So it is always expressed in 3 digits. For example, if this bearing value, for example, if it is 215 degrees, it is right like this. It is a reflex angle, so of course it is going to be in 3 digits. But over here, if you talk about this bearing angle, this is clearly an acute angle value. So it's definitely going to be in 2 digits, and you have to write the bearing in 3 digits. What you're going to do, you're going to write one extra 0 in the beginning, and then you're going to write the angle value. For example, if this is 60 degrees, just for instance, you're going to write 060 degrees. This is going to be the bearing of B from A. That's how to write it. Okay? That's it. Now, we are going to move the past paper questions. I hope that the concept when to use which formula is somewhat clear in your mind. Okay. And next, we have to move to our past paper questions. Alright. So I have just accumulated few past paper questions related to these topics. We'll try to solve them here. and we'll see that how we apply the formula after reading the nature of the question. Okay? Load here my document. Will take a few seconds to be on the board then. Okay, alright. So, on trigonometry, okay, there you go. Once when you will see the document on the board, I need you to write yes in the chat box or one in the chat box so that I can be confident that yes, the viewers can easily view this. It's going to take a little time loading. I hope. Let me just refresh it. It's just 7 page small document. Okay, now it's here. Pretty good. I hope you people can see the document here on the whiteboard. If yes, then please respond in the chat box if you can easily view it. Yes, people? Please write yes or one in the chat box if you can see the document on the whiteboard. Can you see it, please? Kindly respond. Yeah. Okay. Okay. All right. So you see, I've just collected a couple of questions from the May June. I've just maintained them in a topical order. Now you can see here a figure. It's given over here. What exactly it is asking us to do, they have just given a little description of this figure. It's a logo design made from a sector and two triangles. You see, this is a major arc sector, and this is triangle number one where you can see my cursor moving, and this is triangle number two. Okay, the sector having center O has radius 8 centimeter, and the sector angle is 210 degrees. AC is 8 centimeter and angle ACB is 72 degrees. This is a little description about this figure. Now in part A, what it is asking, uh, and let me just remind, this is the 2016 paper 4-2 question number 7. Okay, we're going to open the marking scheme as well so that we can view, we can tally the answer from there. Okay, so I'm going to open the marking scheme cell. There you go. Papers in the marking scheme there are available here on the My Maths Club website. You can see that. Okay, so we are picking up the marking scheme of May, June. I'm picking up 2016 paper 4-2. This is 2016 paper 4-2 marking scheme here. Question number 7. We are going to pick it up here. This is question number 7, and I'm not going to see the answers at all, and we are going to solve it first and then we will tally the answers. Okay, students. Now, what do we need to do here? We need to show that the angle OAB is 15 degrees. Where is angle OAB? It is over here. OAB. This is it. Okay, we need to find out this angle. Okay, so you see, this is a clear isosceles triangle OAB. Why? Let me just redraw it here for your convenience. This is an isosceles triangle. This is O. Because you see, OA and OB are the radii of this major sector. So radius is always same. So if OA and OB values are 8 centimeters. The two of the sides are having the same length. This is a 100% isosceles triangle, right? So if we succeed in finding this angle, we can easily find out the required angle over here. Okay, so what is the angle AOB here? We need to find this angle first, okay, before finding out our OAB. So we need to find out this angle. Let me just remove this word here. Okay, we need to find this one first. You know that this full angle is 360, yeah? So if you subtract 210 from 360, you can find out easily this angle AOB. So 360 minus 210, what it gives? It gives me 150 degrees. Yeah. Now you pick up, we need to find out the required angle now. So you know that the sum of the interior angles of a triangle is always 180. And you know that in isosceles triangles, the angles which are present with respect to the similar sides, these two angles are always same because their corresponding sides are same. But these angles are also equal. Okay, if I just say that let X is angle OAB, yeah, is equal to angle OBA, and I just represent them by letter X, small letter x. Okay, so the sum of the interior three angles is equals to 180. Now you can easily simplify that. You are rich enough, right? So it's 2x equals to 30 degrees. So x is equals to 15. That's it. Okay, so they were asking you to find out OAB, and we just did that. It's 15 degrees, 2 marks question, 2 mark working. Okay, so make sure that you have to mention each and every step. Don't try to be too much direct in your work by saying that it is just of 2 mark. So just do a direct work. Don't be like that. Always mention all the relevant steps. Okay? Don't give examiner a chance to cut your marks. So now, come to part B. I hope part A is clear to you. If it is clear, please write 1 or yes in the chat box. I appreciate your responses. Yes. Is this thing clear? Yeah, I need you to answer. Is this procedure clear to you? Thank you, Hiba. Thank you. Okay, now come to part B. Calculate the length of straight line AB. Now this is the beautiful part they're asking. It's a 4 mark question. Okay? So you need to find out this length. Okay? So what do we need to do? You are handling here an obtuse angle isosceles triangle, right? You see, triangle OAB is obtuse angle isosceles triangle. One of the angle is obtuse, not obtuse, yeah, obtuse. It's 150 degree here. So one of the angle is bigger than 90 degrees, so it is obtuse angle isosceles triangle. So you need to find out the unknown side. You can't use Pythagoras theorem. You can't use trigonometric ratios. Nothing over here. You can use either cosine law or sine law to find out the unknown side. Okay. So I've been given here two sides, and I know all the three interior angles, right? So I can use either sine law as well as cosine law both. I have freedom. So it's just a 4-mark question. You have freedom to use any of the two formulas because the two sides and three angles are given to me. I can use any formula here. So I picked up sine formula here. I need to find out my AB. That's what I need to find out here. So sine of 150 degrees. Okay, the side which is right opposite to this angle is AB, right? This is the side which is right opposite to 150 degrees. So this is my AB. I'm using the formula equals to sine of, you see these remaining 10 angles, they are of 15 degrees. And 15-degree angles right opposite to this side, which is having 8 centimeter length. So sine 15 degree upon 8. That's it. Now you just make little nice swapping here, and you are going to get your AB length within no time. Okay. So do a little swapping. Mention this step. Don't skip it. So it will go here. 2 will go here. I'm sorry, not 2. 8 will go here, and sine 15 will go in the denominator. So that's a little swapping. So just do it. And then you're going to use your calculator to get the value of your AB. And there you go. Within 3 beautiful steps, you're going to get your answer, and the 1 mark is for the answer you're going to write on the blank. That's how the 4 marks are going to be adjusted. So let me open my calculator. Here. Okay, so 8 times sine 150 divided by sine 15. Okay. And it's 15.454, and you can round it. You can write 15.5. That's okay. That's a good representation. 15.5. What should be the unit? The unit is in centimeters, so write centimeters. And you just write your answer here, 15.5 centimeters. Okay, 3 steps for the solution work, 1 mark for the answer. That's how the 4 marks are adjusted. Okay, so this is it. Now let's check the answer from the marking scheme, and there you go. Correct. Okay, 15.5. That's beautiful. It's good. Okay, once this is done, we are now going to move to part C. And part C says you need to calculate the angle ABC. Let me just erase this. Okay. Now what do I need to do? I need to find out angle ABC. Where is angle ABC? A, B, B. Let me just move my pointer carefully. A, B, and this is. So guys, you need to calculate this angle here. Okay, this is the one that I need to find out. I've just explored that my AB is 15.5. Yeah. Okay. Now see carefully. 2 sides are given to me, and the angle which is not present at their intersection, this is given to me. Side, angle, side. This angle is not present at their intersection. So I'm going to use which law? Can you write in the chat box? Which one do I have to use? Sine law or cosine law? I appreciate if you answer promptly. Yes. So which law do I have to use here? Sine law or cosine law? And I'm going to use sine law here or the cosine law here. Which one? Yes, you see, if the angle is present at the intersection of the given sides, if it is given over, if this angle is given to me, then I'm going to use my cosine law. But this time, this angle is given to me, which is not present at the intersection. I'm definitely going to use sine law here. Okay, I've just explained over here in the beginning when we were doing this. Okay, so let's try to do the calculation. We're going to use sine law here. So I'm going to erase this work and I'm going to do my part C calculation here. Okay, so I need to find out angle ABC. So this is the angle I need to find out. And this angle is right opposite to AC length, right? So sine of angle ABC is right opposite to side AC, which is 8 centimeter, equals to, now opposite to 72 angle 72 degrees, right opposite to 72 degrees, which side is present? I mean, which side is right opposite to 72 degrees? Can anybody answer? I appreciate if you write in the chat box. Which side is right opposite to 72 degrees? Yes, please. Of course, AB. AB is the side that is right opposite to AB. Okay, right opposite to 72 degrees. This is the side. So you're going to write here 15.5. This is the AB length, which is right opposite to 72 degrees. Clear? Now you're going to find out your angle ABC within no time. It's just a 3-mark work. Okay? You just move your 8 on the other side. It will be 8 times sine of 72 degrees upon 15.5. Now active your calculators, get the value of sine angle ABC is 8 times sine of 72 degrees divided by 15.5. Yeah, 0.49. I just keep this value safe in my calculators, alright? So I just keep it safe. And this is 0.49. Now you see I need to find out ABC length. So what I will take sine inverse on both sides because I have to remove the sine thing here. I have to remove this. In order to remove this, I will apply inverse function on both sides. Okay. So once when I apply inverse function on both sides, this is going to cancel the effect of the original function sine. And that's how they both will get vanished. Okay, and on the left side only angle ABC will left. That's why you directly use your sine inverse and you get the answer. This is something extra I'm telling you. You don't have to show it in your work. Okay, you can write it in your notebook just for understanding. Okay, so angle ABC is equals to sine inverse of this thing. Now go back to your calculators. Okay, save this answer. Take sine inverse answer, and 29.39, approximately 29.4 degrees will be will be your final result. Make sure that while using your scientific calculators, you should adjust your calculator in the degree mode if you are using degree values. If you're using radian values, then adjust it on the radian mode here. Okay, be careful in that. Otherwise, you are going to get wrong answers. So 29.4 degrees is your answer. Angle ABC, 29.4 degrees. Let's check the answer here. Uh, okay, yeah, that's right. It's correct. The answer is correct. And now we move to part D. And let me just drag this document a little down. There's too much work here clustered. So let me just move it here. Okay. We need to calculate the total area of the logo design. It's a 6-mark question. Okay. It's a 6-mark question and it's very, very interesting. Okay. People might be thinking this is a 6-mark, it should be hard. It's not hard, it's very interesting. Okay. So you see, you need to find out the areas of the 3 individual segments of this logo design. One segment is the sector of the circle. This is segment number 1, whose area you need to find out. You call it area of A1. Then you need to find out area of this small thin triangle OAB. You call it A2. Okay. And then you're going to find out the area of this prominent triangle ABC. You call it A3. Once when you find out all the 3 areas, then you're going to sum them up. You will get the area of the entire logo. Fine. That's the thing you're going to use 3-mark work for each segment of 2-mark work for each area finding. Okay. Comparatively, it is 6 marks. Now, what to do? Which formula do we need to use to find out the area of the sector? Can anyone tell me in the mic? I appreciate that. What is the formula of area of a sector? You can see in your books as well if you don't have a number. Area of a sector. OAB. Okay. Yes, guys, be responsive, please. Don't you remember the formula of area of a sector? Whenever the angle subtended by the sector is given in degrees, what is going to be the formula of area of a sector? It is going to be theta upon 360 multiplied by pi r squared. This is the formula of area of a sector when you are handling angle in degrees. If you are handling angle in radians, it is going to be half pi r squared. And that's it. So now, what is your theta here? Theta is 210. Is the angle of the sector divided by 360 multiplied by pi multiplied by radius. Here the radius of the sector is this. Okay. Presently you are handling this portion. Okay. So this is 8 and this is 210 degrees. Clear? So this is 8 squared. Got it? Okay. Now to solve it and get your answer. So what we do, we just pick up our calculators and 210 divided by 360 multiply by pi multiply by 64. 117.286, so you can approximate, you can write 117.3 centimeters squared. Okay. 117.3 centimeters squared. That's it. Okay, now you just try to find out the area of triangle AOB, which is A2. Okay, this is my area of a sector. I call it A1 for my convenience. I'm going to find out area of triangle AOB. Next thing is area of triangle AOE. That's it. So this is A2. The major formula of area of a triangle is what? At least you should know the formula of area of a triangle. So what is that? Can anybody tell me in the mic? Yes, Farooq. Yes, Siva. Can you tell me? The formula of a triangle is quite a basic triangle formula. Very basic and intrinsic formula. Half base into height. This is the major, very primary formula of finding out the area of a triangle. Yeah. Okay. So when you're handling with this thin triangle, let me just draw it here. It is a very thin isosceles triangle. This is O, A, B. You know that these angles are 15 and this is 150. This is 8 centimeters. This is also 8 centimeter and this is 15.5 centimeters. Yeah, 150 degrees. This is 15 degrees. This is also 15 degrees. Where is base? What is the height? We have to decide this on our choice. Okay? It's your choice which side you're going to pick up as a base. On that basis, you're going to draw the height of the triangle. So here the very easy going side to consider as a base is AB. Okay, if I pick up this side as my AB, okay, and the height of the triangle I'm going to draw with respect to the vertex, it is right opposite to AB. It's the vertex O. So at O, I'm going to draw a line falling perpendicularly on the base AB, like this. I don't want arrows. I need line options. This is it. And I'll make it dotted. That. So this is the height. Okay, a dotted line. Okay, I call it OX. This point X. I need to find out this length. This is the height of the triangle. Yeah. So half times base is AB. And what is going to be the value of my OX? That's what I need to find out. Clear? So you can use the formula of your, you have just split up this isosceles triangle by with the help of this dotted line, and now this isosceles triangle is divided into two right triangles, right? So this is a right triangle now. OXA is the right triangle now. You can use your sine ratio formula. So you see, with respect to sine 15 degrees, opposite side upon hypotenuse, which is 8. So I can represent my OX as 8 times sine 15 or OA times sine 15. So this is OA. I must not write the values directly. I should write the line segment starting and ending points. This is OA. Okay, so OX is actually OA times sine 15. Yeah. So this is the sine formula to find out the area that we use. So this is OB times OA sine 15. Here, substitute the value of AB and OA. AB is 15.5 and OA is 8. You are going to get your area A2 within no time. 15.5 and this is 8 times sine 15 decreased. Now let's calculate this, and once when we solve it, we just come to know that A2 is 16.05 centimeters squared. Correct? So the area A2 is this. Clear? Now the third thing is so left is to find out the area of triangle ABC. Okay. So how we are going to find out this area? It's also very easy. You see, you know the value of your AB is 15.5. This is 15.5. You know that this angle has just been calculated. It was 29.4. We did it in part C. Two sides and two angles are known to us. We can easily find out the area using sine formula. Okay, sine formula to find out the area. Now how we find out our A3? If we pick up AC as our base, or if we pick up 15.5 as our base, we can easily find out the area. Okay? We're not going to pick up BC as our base because we don't know its value. Okay? So we are going to pick up the given sides only, whose lengths are given to us. So if I pick up AB as my base, then the C is the point or vertex right opposite to AB. So I'm going to draw the perpendicular line over here. This dotted line is the height, which value I need to find out. Okay? So my A3 is half times, what is my base? My base is AB. Okay, and my height is C. I call this point X. Okay, so height is CX. I know base value, AB value is 15.5. I need to find my CX. So I pick up this right triangle. Okay, so sine of 29.4 decrease is equal to perpendicular, which is CX, divided by, okay, if I take this, then BC will be the hypotenuse. Okay, I must not take this. I should take 78. I can find out the third angle as well very easily. I can find out the third angle. I can easily find out angle A by subtracting 72 and 29.4. Yeah. So hang on. Okay. So my angle CAB can be obtained by subtracting the given two angles from 180. I can find out. So this is going to give me 78.6 degrees. Okay. So this angle, this one that I'm just going to color, this is having value 78.6 degrees. Okay, so this is it. So if I pick up this right triangle, this one, I can find out my CX value easily. So you see, sine of 78.6 is equal to CX, which is perpendicular upon hypotenuse is 8 centimeter. Okay, so I can now easily find out the value of my CX. So calculate your CX, which is 8 times sine 78.6, 8 times sine 78.6 is 7.84. Alright, so this dotted line length is 7.84. Done. Now height is known to us. Now we are going to use this height formula, a value in the formula, and we are going to get the area of this triangle. We just come here and half times 15.5 into 7.84. This is going to give me the value, which is going to be 60.78 centimeters square. Okay, so this area is known, thin triangle area is also known, and the sector formula, sector area is also known to us, 117.3. We're going to sum up all these three triangles, all these three area values, and we are going to get the area of the Lugo. Okay, so once when we sum up, the area of the Lugo is going to be 117.3 plus 16.05 plus 60.78, and guys, we are having now the final area, which is 194.12 centimeters square. Okay, check the formula and check the answer, and it's 194, and that's it. Okay, it's done. So the formula of the area of the Lugo has just been evaluated. It's a 6-mark work. Find the area of the sector and find the area of triangle AOB with the help of sine formula, and then find out the area of triangle ABC with the help of sine formula area. Then sum up all these three values, you will get area of the Lugo. So that's it. Okay, so that's major thing done. So you see, in this formula, we have in this question, we have used the right triangle formulas ratios, we use cosine law, we use sine law, we learned how to do the work, okay, after looking the nature of the question. So more you do the past paper questions, more you get perfect. Okay? Now if I just do one more question related to the bearings, okay? That's it. I'm going to remove this rough work all around. Okay. Okay. Now this is 2016 paper 4-3 question number 5. Got it. Now what do we need to do here? They have just given us a figure that explains the journey of a plane. It says that a plane flies from A to C and then from C to B. This is the proper journey trajectory. Then they have given us the length of AC and BC, and they have given us angle ACB, which is 40, and they have given us the bearing of C from A. Okay, from A means you have to draw your north axis at point A like this. Okay, this time I need arrow. Just like this. Okay, and I'm going to turn it solid. I'm going to change the color just to make it prominent. That's it. Okay. Okay, so they have just said that the bearing of C from A means you are handling CA line segment or AC line segment. You are going to start the angle calculating from the north axis in a clockwise order till it ends over here. So this is the bearing value, which is 135. That's what they have given to us. Okay. We need to find out the bearing of B from C. Okay. So you see, the north axis is already drawn at C. You have to calculate the angle from here till it ends at BC line segment. That's what we need to find out. Just 2 more questions. What to do? You see, this full angle is 360 degrees. This full angle is 360 degrees. So if I subtract this 40 degree and I subtract this angle, and I can easily find out the bearing angle, isn't it? Isn't it? So I need to find out this angle, this value. Okay, that's my first objective, the first step that I need to take here. Okay. So what to do? If I extend this AC line a little here, okay, I extend it like this, and then if I just draw here, according to the corresponding angle concept, you see these two north axes are right parallel to each other, and this AC is behaving as a transversal, like this. Okay? So whatever the angle over here is the angle over here according to corresponding angle concept. So if this is 135, then this angle is also gonna be 135. Yeah. So this angle that I need to find out first is actually the supplementary angle. This angle is supplementary to 135 because this full angle from here to here is 180, right? So if I subtract 180 from and 135, it's going to give me 45. Okay, so this is 45. So once when I subtract 40 and 45 from 360, I'm going to get my angle is 275. So this is the bearing of B from C. And you can see that this is a complete reflex angle, is greater than 270. So it is a reflex angle. So it is 275, and that's correct. Let's check it out. I'm talking about 2016 paper 4.3. So 2016 paper 4.3, question number 5, part 1. There you go, it's 275. Okay, that's beautiful, that's it. Similarly, find out the bearing of C from B. That's the next part related to the bearings. C from B. You need to construct the north axis at B. Because B is actually written after from. This is the hint that you need to draw your north axis here. Okay. Now, what to do? How you're going to find this out? What is the value of this? So for that purpose, we are going to make a little modification here. And what is that? I'm going to extend my BC line segment a little beyond, like this. Okay. According to the corresponding angle concept, whatever the angle over here is the angle over here. Right? So I need to find out this angle. This angle and this angle are same because they are corresponding. Right? BC is behaving as a transversal of these two north parallel axes. Right? So you can find out this angle by subtracting 40 and 45 from full 180. Am I right? So you can find out the bearing of C from B by subtracting 40 and 45. This is giving me 95 degrees, so write in 3 digits. This is it. This is the bearing. That's how you do it. Okay. So you see, 1 mark is for the modification that you do in your figure, and 1 mark is for this one step work. You got 2 marks. That's it. Okay. So that's how you handle your bearing question. Simple. It's done. So that's all that we are going to cover in this master class. Now we come to the tips. Okay, what are the tips and strategies to improve your performance in your mathematics? Okay, what is that? You see, we don't have such rocket science here. What you need to do, always remember that once you are studying mathematics, you have to study the theory of the topic. Whatever the topic you're studying, you have to study the theory. Okay, study the theory first. Then you have to move to the examples. Try to understand the examples. After that, once when you see that you have well understood the concept, you have understood the formulas, when to apply what, you have just understood the examples, then you move to your exercise questions. Try to solve the exercise questions. Once when you just handle all the exercise questions, you have completed the assignments and all that, at the end, you are going to move to the past papers. Okay, this is something that you are going to do at the end. That's the last step. So once when you gain mastery in that, the fifth thing that I really appreciate and I really insist all of my students they should do is to do the group discussion. Try to teach your classmates in the group study. Try to teach the friends which are also studying the same syllabus of yours. Try to organize little group discussions. No matter if you're an introvert, people remain comfortable among friends, right? So try to make group discussions, okay? And don't ever try to rush in the topics. Don't skip any topic. If you skip the topics, then you are going to be in a big trouble because you see, in mathematics, all the topics are interrelated to each other. If you skip topic A and you try to jump to topic B directly, it's definitely going to cause a havoc in your study. Okay, so don't skip the steps. Don't skip topics. Okay? Study everything. All right. The last thing is that always try to organize yourself. Okay? Keep yourself organized and disciplined. Try to give at least 4 days in a week for the math practice. It is very crucial because maths demands practice. Okay. Uh, these are the very key points you should adopt. If you haven't adopted yet, try to adopt it. Try to exercise on it. Okay? The last thing is that if you feel that your class lectures are not sufficient for you, then you should take the service of any home tutor or online tutor, whatever you want. Alright? Try to take their service, discuss your theories and your confusions with them, and take their time. They are definitely going to help you because they are very honest and very passionate and very, what to say, they are a very adhere people in their profession like that. So this is it. Indeed, if I talk about our website, mymathsclub.com, we offer online group-based live classes just like this. And for IGCSE mathematics, we give 2 classes weekly of 1.5 hours each. Okay, and along with the classes, if those students who take our get enrolled with us, we used to give them free ebooks. We give them free AI-powered workbooks, topical past papers. We give them class recordings as well. If they, for example, accidentally, if they skip any class just for because of any reason, we give them class recordings as well of the live lectures that they are going to revise, and they are going to go over through the thing that they have missed. And we give access to WhatsApp students group to them so that they can make mutual discussions. These are all the perks that we offer along with the live classes, and along with that we give 10 days money back guarantee. Okay, within first week of the month, if you feel that you don't want to continue with us, you can ask for the refund, and we are going to give your entire monthly payment back to you. Okay, and the last thing, we give 25% discount in our monthly payment. Okay, so if you feel that you need to take our service, if you are interested, then you can go to the live classes section, and you can go to the IGCSE online maths tuition. There you can select the required course. If you want to study additional maths, you can pick up this. If you want to study extended maths, you can pick up this. Okay, and then you can select, you can give the payment, you can join us. And the class links will be given to you in the WhatsApp group and to the emails as well. So if you're interested, then you do let me know. And it's really nice to have you guys here with me in this master class. It was wonderful to have a discussion with you. That's all for today. Take all good care of yourself, and remember me in your prayers, and I'll remember you. See you then. Allah.